Okay, YouTube, in this video we're going to be kind of as a precursor to solving matrix equations, we're going to be looking at what we refer to as the multiplicative identity matrix. And so identity matrix, let's go ahead and wrestle with this term identity. I guess an identity is anything that under a given operation doesn't change the thing you're operating with it. And so that is to say with real numbers, we talk about a multiplicative identity as being a number like 1 because when we take anything times 1, then it stays the same under this operation of multiplication. So we would say that 1 under the real numbers is the multiplicative, okay, identity because it is the element in the real numbers that under the operation of multiplication, if we do anything with 1 and multiply by it, we're going to get the same thing we start with. So that's something we're really interested in doing with matrices as well. It's just that the question remains, what could I take times a matrix A in order to get A? And so in this video, we're going to introduce what we refer to as not the identity element, but the identity matrix. So we say that there is a matrix I such that any matrix times I is equal to itself, or any I times that matrix is itself. So we say yes, there does exist a matrix here that we can multiply by A, and we refer to this matrix as I. So that is to say that I is going to be what we call our identity matrix. So what do we know about the identity matrix? Well, one thing that I want to point out right off the bat is this. An identity matrix is a square matrix. So a square matrix is our identity matrix here, which means that it has the same number of rows as columns. And the way this works is we say that it's a square matrix with ones down the main diagonal from upper left to lower right and zeros elsewhere. That matrix right there, when we multiply by it, does not change the elements in a matrix in the products with that matrix. So essentially, if we were to look at an identity matrix of order 2 by 2, this would be a square matrix, then as they've described it here, really what we're looking at is ones down the main diagonal and zeros elsewhere. And according to what we've got written here, we would essentially say that any matrix that can be multiplied by this 2 by 2 matrix, it will stay the same. So that case is illustrated here, and we see that we have some matrix A, I suppose, because it's full of all these little a's. So we have A, first row, first column, first row, second column, second row, first column, second row, second column. If we take this times 1, 0, 0, 1, we would get the same thing we start with. But what I want to point out is the reason why this works. Because we take a 2 by 2 times a 2 by 2, it's defined because our inner dimensions match, and we get a 2 by 2 answer. But to get this right here, say it's in the first row, first column, what I want you to see is happening is we're taking everything in the first row in our row matrix times everything in the first column here. But what ends up happening is we get A11 times 1, which is A11, plus now A12 times 0. So that A12 times 0, that kind of cancels out and just leaves behind the A11. If we were to look at, say, the first row, second column, first row, second column in order to get this A12, the reason why that we get this is because A11 times 0, that wipes out, plus A12 times 1. So you can see that if we were to go through all of the multiplication here, we end up with the same matrix that we start with, essentially. And another thing that is really important to mention here is because matrix multiplication, we've learned that with matrix multiplication, A times B isn't always equal to B times A. So I'm going to say always, not always, okay, equal. So we would say that since order matters here, then we would be careful of this. But even if you took this I matrix, this identity matrix that is what we'll call identity 2 by 2 or just I2, and took it times this A matrix here, we still end up with A. So the identity matrix, what we want to carry away from this video is this. We say it's the n by n square matrix with ones down the main diagonal from upper left to lower right and zeros elsewhere. And we'll refer to this as just our multiplicative identity matrix of order n. And the reason why we write it as just in and not in by n is because everybody assumes that you know that it is a square matrix. So we write these matrices as in. You can see here that I2 is given as this 2 by 2 matrix with ones down the main diagonal and zeros elsewhere, and I3 would be this matrix right here. So what I want to do very, very quickly here is this. Let's suppose that we have a matrix A, and this matrix is just very simply put, we'll just go 1, 2, 3, 4. Could we take this times the identity matrix, and in this case we'd have to multiply by the identity matrix of order 2. So if we took 1, 0, 0, 1 and we multiply these together, checking this out, we should end up with A. So we get 1, 2, 3, 4 times now our identity matrix, which is ones down the main diagonal, zeros elsewhere. We know that this is defined, certainly because the inner dimensions match, and we know that we'll get the outer dimensions on our answer here. So the first thing we're going to do is fill in this 2 by 2 over here where we're going to start chasing after individual entries. So first row, first column, we would say first row times the first column, we get 1 times 1 plus 2 times 0. So in other words, we just get the same 1 we started with here. If we go first row, second column, we get 1 times 0, which is 0, plus 2 times 1, we get a 2 here. Let's go second row, first column. So this entry here, we would say second row, 3 times 1 plus 4 times 0, so that's a 3. And then second row, second column, 3 times 0, which is 0, plus move over, move down, 4 times 1, we get 4. So we get the same thing here. So the last thing I want to kind of present is this. I went ahead and I went into my matrix menu, and I've already put in for matrix A here 1, 2, 3, 4. I'd like for you to try the same thing here, but what I want to point out here is that we don't have to actually put in the identity matrix 2 by 2 for, say, a matrix B, because if you go over to your math menu here, under math you'll see identity. So just really quickly here, as you see identity here, when you click on this, it's going to say identity what? Well, when I hit identity 2 and I hit enter, you'll notice that this just means that this is our identity matrix of order 2, whereas if I would have hit identity 3, then it would have just been our identity matrix of order 3, and as I hit enter here, sorry, let's try this again, math, we want identity, not dimension. So identity 3, and I hit this here, you can see that we're getting our identity matrices. Well, what I want to do is I want to take my matrix A. So since I put it in, I'm going to say A times, now matrix, and we'll go to identity 2. What we know is anything times the multiplicative identity should just be the same thing we started with here. So let me try this again here because I seem to be clicking on all the wrong things. Identity 2. And what you see is we get the same matrix that we started with here. So it is indeed the case that A times I is A, and also I times A is A. So that's our multiplicative identity. We just want to be aware that it exists. In the next video, we'll talk about how we can obtain it. Cheers.